Hey, morning everyone. Welcome to RubyConf Taiwan 2023. And I hope you have a great experience today. Can you raise your hand if this is your first time here? Oh, not only me. Okay, thank you. Okay. Um, uh, so we sorry for starting late because the schedule. And if you have any question during the speak, you can go to RubyCon Taiwan 2023 website, and there is the under the speaker avatar we have like a Slido web. Then you can write down your question there, and I will have you to write the ask the speaker later, or you can ask him directly. So our first speaker, Ryo KAJIWARA, he will talk about the adventure in the dungeon of OpenSSL. We're gonna start now. Thank you so much.
Welcome to my talk. Yeah. I'm Ryo KAJIWARA, and so let me see. Yes, slides are available right here. Please make sure that this QR code gets this URL. I am not presenting anything malicious. Uh, yes. I'll wait for like 30 seconds so that you can get the slides. Like I have like 82 pages, I believe, and this is going to like I will go through like very like advanced stuff that you might want to look it up later. So yes, this is, slides are available online, and I'm gonna start in like 5 seconds. 4, 3, 2, 1, and let's go. Hello everyone. I do a lot of stuff. Yeah, lots of stuff. This, if anything captures your interest, well, let's talk later. And I do a lot of stuff that is more relevant to this talk. I am a freelance web developer focused on digital identity and security, and I'm currently mainly working at CodeTact on developing ID platforms for public schools. And I've been working on writing, editing, and implementing internet standards. So I've worked at HTTPS and local network community group and the Web of Things working group W3C and OAuth messaging layer security working group in the IETF. And I've worked as an officer of Internet Society Japan chapter for 4 years. And I'm from the forgotten realm of Japan called Shikoku. Do you find anything wrong with this map? There is an island missing here, and I'm from this island. And so, yes, my ticket this time was from Matsuyama, Mats Mountain of the Songchang, yeah, the other Matsuyama. This picture is the clock that exists in Songchang. Uh, this design comes from clock that also exists in Matsuyama's Dogo Onsen. So I heard that the direct flight from Taoyuan Airport to Matsuyama will resume operation next March. So if you have a chance, please visit us. So that's my introduction and cost. There are some cautions before I start. I am going to be talking about dungeons. So there be dragons. Dungeons and Dragons, am I right? Yeah, my t-shirt's also Dungeons and Dragons, so yeah. And also, my first Rio, that happens to be a Chinese dragon character, so also Dungeons and Dragons there. So yes, I'm gonna be talking about cryptographic API, and cryptographic API can be very easy to misuse, and like you might have heard in RubyConf that parse Y is a demon castle. Like, what's different from like dungeons like parse Y Vania is that you can actually hurt yourself with cryptographic API. Do you like security breaches? I don't think so. So please be careful with cryptographic API. Like I've done my research into stuff. Like last time I talked at RubyConf Taiwan, I talked about SHA-3 in like G language, but like I don't consider myself a cryptographic expert because I don't have a PhD or master's in this field. So yeah, I'm a cryptographer in the wild. So if you're not sure, if you're not like, if you want to be really sure, please get your system audited by a security expert before going into production. So there are like varying levels of production readiness in my talk. The HPKE gem that I'm going to be talking about first, that's almost ready. Like there could be minor changes in the API somewhere, but like it uses pretty much safe stuff that I reviewed. But like the gem itself, it hasn't been audited by a security expert. So yeah, if you want to be really sure, please do that. But the OpenSSL extension part that I'm going to be talking about, the latter half, definitely not. It is very experimental. And there's past related works that inspired me to get talking about this. That it's RubyConf 2021 talk by Yusuke Nakamura-san, or probably better known as Unasuke-san, titled "Do Pure Ruby Dream of Encrypted Binary Protocol?" So he talked about implementing Quick Quick or HTTP3 in Ruby. He talks about the pain of handling the hex-coded and raw strings in Ruby. By the way, the answer to this, the title is yes, it does. I'm going to be talking about one today. So that's the introduction. I wanted hybrid public key encryption, HPKE, or RSC 9180 in Ruby. And I'm going to do a quick recap about public key encryption. So how public key encryption works is Alex generates a public private key pair and publishes her private key. Then Bob encrypts a message with public key. Then Alice can decrypt it with private key. That's a basic public encryption. By the way, I am going to throw a lot of these like cryptography words, cryptographic algorithm names and stuff during this presentation. I'm not going to explain most of them. Please look them up later. So, what is HPKE? If you know about TLS, we use like encrypt the session key, a random value, with public key cryptography, like RSA. Then you send your messages using the symmetric ciphers, which is the encryption method when you use the same key to encrypt, same key to decrypt, like AES. You don't do like, why do you not do everything with key cryptography? Because it's costly. It's way more costly than doing a symmetric ciphers like AES. Then there's a problem. Like there are lots of misuse and implementation bugs in cryptography. Like one famous one is PKC's #1 padding in RSA was like it led to a class of attack called Eichenbacher's Oracle attack. It like simply said like bad padding methods enables you to decrypt messages like way earlier, way easier than the theoretical limit. And like there's also the problem of nonce reuse, random value reuse. Like one famous example is the leaking of ECDSA keys of placing 3 code signing. Like what happened is they used the same random value every time they code sign. So using that, you can get secret key of the PlayStation 3's code signing. What happens is you can sign homebrew and pirated software as legitimate. That is a nightmare of a hardware developer. So yeah, you don't want that. If you've been using AES, please check your implementation that your initialization vector is random all the time. And so you typically don't want to decrypt with elliptic curve cryptography. You might have heard of ECDSA or X255.9 with on your SSHs. That's where it comes. You get key exchange additional signatures, but not encryption. So the encrypt with public key trick that like we mentioned first, that doesn't work in ECC. So HPKE tries to solve this using standardized and reviewed protocols to like do the key exchange and encryption, and also it's standardized using best cipher suits or combination of algorithms possible now. And also, the best feature about HPKE, it uses high-level APIs that prevent misuse. So if you are using the high-level APIs of HPKE, you are like pretty much safe from misusing it. And HPKE comes three parts. It uses a key encapsulation mechanism, KEM, and the part that makes the key itself is a key derivation function, KDF. Then then you use the symmetric keys to perform authentication encryption with associated data, AEAD. And how we use HPKE, HPKE is a one-way protocol from sender to receiver. So if you can agree symmetric key through this using a secret exporter, but most of the time the HPKE is one way from sender to receiver. First, receiver creates a public-private key pair, publishes it, uses a public key to encapsulate the session key, the random value, then uses a session key to encrypt the message. Then sender sends the encapsulation of the key and the message in two parts. Then receiver uses the encapsulation. Capsule opens it up to encapsulate session key, then uses that session key to decrypt the message itself. So yes, I wanted HPKE in Ruby. So what I tried looking at the specs, I try to find out which part was available in Ruby. These are the stuff you need to implement HPKE. KEMs need elliptic curve support, and like KDFs need like hash function support, like SHA-256, SHA-512, and like authenticated encryption with associated data. That's like the metric ciphers. So all of this should be supported by OpenSSL, right? Well, it's kind of boring, not all the way. So we had AES-128 GCM, AES-256 GCM, and CHA-20 Poly 1305 available in the test OpenSSL test cipher.rb. So, but CHA-20 Poly 1305 isn't in the test code, but you can use the same API as AES. Then it works. You can change the name, and if you're using the same block size, it works. And for HMAC SHA-256 and 512, like even if we didn't have HMAC support, but we had only SHA-256 or SHA-512, I can implement HMAC at any time. But like, actually, we have the HKDF that relies on HMAC, but we needed to customize some parts of the HKDF to use in the HPKE. So having the HMAC was good enough. And the stuff it kinda had, it was the elliptic curve, P256, P384, and P521. It is not 512. It's not a typo. They're in test OpenSSL test PKey ECRB, and X25519 and X448. They are in test PKey.rb. So I've mentioned test codes here, not like Ruby reference manual stuff. So yeah, the question is, really, these seem to be undocumented. And the answer, yes, it is undocumented. And some APIs in OpenSSL are intentionally left undocumented so that like people who doesn't know cryptography doesn't misuse randomly tries to use it and misuse it. Yes, misusing cryptography can hurt yourself. They lead to security breaches of like very messy security breaches. And there are a set of classes called OpenSSL PKey that handle everything public cryptography, including RSA, DSA, Diffie-Hellman, and curve cryptography. And what it does is there is a struct in C struct in OpenSSL called BBP PKey, which handles the state and stuff. And this class is a wrapper for the struct. And note, like X25519 and X448 are actually elliptic cryptography, but doesn't use the OpenSSL PKey EC because they are. I will not go into details, but they're like implemented differently. So looking at the specs, I found out like I needed a way to make OpenSSL PKey that has a secret key, private key value of a specific binary value. It looked like there was a way to do it for OpenSSL PKey EC, but not for X25519 and X448. So I started working on that. There was a pull request that worked on this, but it was 3 years old, and it wasn't working on some older versions of OpenSSL. So I started working on this by like fixing the errors in the CI matrix, then addressing review comments, and I got this this pull request merged. That was my first Ruby C extension experience and my first actual commit into Ruby OpenSSL and Ruby Ruby. So while I was at it, the OpenSSL P key became immutable after OpenSSL 3.0. So you think you can do you can instantiate an OpenSSL P key EC object like saying .new, and you can set P key .private for key using a random 32 byte random string. This works in pre-OpenSSL 3.0, not after OpenSSL 3. Note that the private key to P256 consists of a 32 byte number. But to be more accurate, it is a positive number under the order of the generator, which in P256, it is pretty close to the maximum of 32-bit integer, but it is not exactly maximum of 32-bit integer. But, like, if you want to be like really paranoid about security, you have to know these stuff. Like this is just an example. So yeah. So in OpenSSL 3.0, we were not just missing APIs to make the X2551448 key pairs. We didn't even have APIs to make the EC key pairs. So I had to come up with a way. Like, how can we make a pair with a specified private key of an EC? This was available. You can write something in the ASN1 DER format that called SSL key read. It is not note that this is reading off certain instructions, then it's creating the instance right here, so it's not like mutating the stuff. So even with the immutability, this works. So what we do is we create an ASN1 sequence, and we convert it into a dir, then we convert it into a PKEC. So this looks hacky, but it even exists in Ruby 3.3 Preview 1. So what is ASN.1? It's the abbreviation of Abstract Syntax Notation 1, which is a set of binary notation rules to code data structures. And specifically, DER, Distinguished Encoding Rules, is a rule set to describe a data structure in exactly one way, so that it produces hash values or digital signatures exactly in a single way. And you might have heard of PM files when you handle certificates and stuff. So that PM files encode certificates, certificate private keys written in DER. Then you have converted it with a base 64. So to get the ASN1 sequence, you generate an OpenSSL key.generate, which creates a random key, then random key pair. Then you say private integer of active one with an H star, which generates a hash hex string. And yeah, you shove that hex string into an ASN1 JavaScript decoder, and you get this. It has an object identifier EC public key, and the name of the algorithm prime256v1, and has a public key part, private key part. So to get a PKEC, you do this backwards. This sequence format of sequence comes from RFC 5915. Then the X25519 X4 comes from RFC 8410, section 7. So note in this one, the octet string right here starts with a 0x04 0x20 instead of just handling just putting a secret. This denotes a 32 byte long. So X0x20 is it's a 32. So 32 byte long octet string with the secret value. So it's an octet string inside an octet string. So somehow the spec is written in a way that like curved private key, the 0x04, 0x20 plus secret, is wrapped inside a private key. I asked the guys who wrote the spec, but they didn't give me a clear reason as to why it is like this. It's just the way it is. So, but does it look good? No, it's ugly. It looks very hacky. It looks especially hacky with that octet string with an octet string trick. So there is a pull request that is working on generating PPs with the specified private key value. It's I haven't been active in this pull request, but like it's going to be it's been worked on. So now we have HPKE in Ruby. It's on GitHub self01/HPKE RB, where you can just gem install HPKE now. Note that it's still in beta. The API might change, but like it works, so you can start using it right now. By the way, we actually had HPKE in OpenSSL itself, OpenSSL 3.2. A pretty recent version of OpenSSL though. But why not write a Ruby wrapper for this? So yes, I did. It did GitHub self01 OpenSSL, which is a fork of the OpenSSL itself. There's a branch called HPKE. The C extension code is in there. This is super experimental territory. Do not use this in production. Use this in production when it gets worse into the Ruby OpenSSL gen. So I'm going to be talking about how to make C extensions. So there's a document in Ruby called the extensions.doc. So you want to know how to like convert C values to Ruby objects, Ruby values, and vice versa. And also you want to know how to wrap C struct like AVBPKey or OSSL HPKE CTX into a Ruby object. Like it was pretty surprising to know that you can wrap a C struct into an object, a Ruby object, but like have the C struct not be visible from Ruby. So that's how this is how you do it. There's a C function called OpenSSL OSSL HPKE CTX new that makes a context, and the encap and field is so you will first make a context, and then as a sender, you call the encapsulation function, then get the encapsulation, then use the same context which wraps the encapsulated key, and call the seal function. So the context is the one that handles the state, and you want that to be a Ruby object. So to make it into a Ruby object, you define the RB data type T, and this then you define how what happens when the GC is called on that certain object. So you when this HPK context is GC, you want it to be you want to call the OSSL HPK CTX free function in the OpenSSL layer so that it doesn't leak memory. Then it's pretty much taken from the OpenSSL key implementation. This part wraps the OSSL HPK context into the Ruby object. Then here we are defining the module, and the module mHPK with RB defined module under OpenSSL. Then we are defining the class context, RB defined class under module HPKE context. So that makes OpenSSL : HPKE : context. And you define the allocator function with RB define alloc func C context. So that C context class. Then the OSSL HPKE CTX lock is the allocator function with and it returns the type wrap struct with that type we defined. And like to generate a key, there's a function called OSSL HPKE keygen, and if you call this, you get a priv and a pub, and priv is an EVPP key, so we can wrap that into OpenSSL P key object. Then pub it says it's an unsigned star, which is the equivalent of a string in Ruby. But which format is it? I had to figure it out. Apparently, for EC keys, it's the equivalent of the priv is a private key object. Priv.public key dot 2 octet string uncompressed. By the way, this OpenSSL key is 2-octet string method that is not documented in Ruby reference manual. It's only in the R. And for X2599, X448, it's the equivalent of priv.raw public key. So this part will show the encapsulation part as an. So you wanted to take the pub and the info is like the arguments in the Ruby. So you want to take out the public pub and info, which is a string. So you want to take out the pub and info as an unsigned char star. So how to do that? You call the rstring ptr macro. Then you call the rstring len macro on to get the length of the string, how many bytes the string is. So then you get enc, which is the encapsulation result, and you want to take that up as a Ruby object. To do that, you create the enc object, which is you create with the rb string new, and the encapsulation char star and the length of that char star, and so you can take out the object, and that's a string in the Ruby world. To develop with OpenSSL, like you want to like run OpenSSL on a specific version because HPKE is only supported in OpenSSL 3.2. So there's a document in Ruby OpenSSL's repository that has a section called testing with different version of OpenSSL. So you want to check out the specific version of OpenSSL, build it, then I wanted to look inside the OpenSSL HPKE CTX struct, but like if I call like this context arrow some member of it, like what's the key inside it, but I got an invalid incomplete type def error, which is an error in the C world that says no, you can't access that thing. This is because the full type of the OpenSSL HPKE CTX is not exposed to the public header files by default, and it is intentional. It is intentional as a security reason. So I moved the internal definitions to the public header files of OpenSSL HPKE. Then I had to recompile OpenSSL and use that specific version to run the code again. Then with that version, you bundle up the recompile the specific OpenSSL directory. Then call IRB with a specific library directory, and OpenSSL loaded as the default. And also see this C string in hex printed into the console. So you have to do printf debug. So what I did is I wrote the RB debug print function, which takes the C string value as an SDR and the length of that string. So you make a Ruby value RB SDR, then you create RB SDR new with that string length, and what you do is there's a function called RBP, which if you are familiar with Ruby, that's the P, that's the kernel key in C world. So it takes the Ruby object. So what you do is you want to do string.unpack1 h star. To do it in C, you call RB fun call. So that's how you call functions in the C world. So you can pretty much do Ruby. This is pretty much doing Ruby things in C. So I'm gonna show examples of the stuff, the C extension version of OpenSSL HPKE. So OpenSSL HPKE is two. So you specify which algorithms you're going to use. Here we are using P256 curve with an HADF that you SHA-256. Then for the encryption part, we use AD128 GCN. So that makes the AAD ID number 1, KEDF ID 1, KEF ID 16. It is mapped internally, and so then we generate the private key, OpenSSL HPKE gen with that specific suit. So that makes that makes a P256 key. Then to get the public key part, you call print.public key. And so we made a public private key. Then we create the sender context. This is what the sender does. First, the sender creates a context with base mode and specified cipher suit. To make an encapsulation, you call it with a public key with a 2-octet string uncompressed. Then you add some info that has to match the sender and the receiver. Then you call the SCTX the context.seal with an additional associated data that is used in AED, which is the 0x01, 0x02 up to 0x08. That also has to match with the receiver. And the plaintext itself, a message not in a bottle. So that gets you the encryption. So you send the ENC and the CT to the receiver. So with those two values, receiver makes a context with the same base mode and suit. Then the receiver with the receiver context calls it decapsulation decap with an encapsulation and the private key and the same matching info. So if this returns true, the RCTX contains the same key as the receiver. So you can RCTX.open with the same AAD and the ciphertext. Then the receiver can get a plaintext, a message not in a bottle. So that's how we send messages in HPKE. By the way, is anyone here familiar with Ruby's encoding? I don't want to use a force encoding when you like try to encode Japanese. I kind of need it now. I need someone who's familiar with Ruby's encoding. Like I've seen someone here, so I'm gonna ask that person. So will this go into actual OpenSSL gem? Maybe. There's still some work to do. This is limited to OpenSSL 3.2, so like we have to say HPKE is not available in versions older than OpenSSL 3.1. So it needs guards against older versions. And it currently supports base mode only. There's auth mode, auth PSK mode, PSK mode, which has like a sender and receiver authentication. But it's I can just add some code. That part's easy. But and hard-coded length values of the buffers, those need to be fixed. Yeah, I kind of fixed the hard-coded buffer parts, but like I'm not sure about if I'm doing it correctly. And I am especially not confident about my C coding skills. So I have reviewed by someone else who's very familiar with like secure C coding. So yes, here were my adventures in the Forgotten Realm called OpenSSL. By the way, this is both a D&D reference and a Magic the Gathering reference. Why did I want HPKE Ruby in the first place? It's the building block for modern security and privacy protocols, such as TLS encrypted client hello, oblivious HTTP, and messaging layer security. I'm especially interested in messaging layer security, which is like an end-to-end encryption protocol for instant messengers. So if we don't have the building block for modern security and networking protocols, people would not implement them in Ruby and just go to Python, Go, Rust, whatever that is popular with everyone that has those libraries, because they have the building blocks readily available. We need modern cryptography in Ruby for Ruby to stay relevant. It is not for everyone, but it is surely for someone. And we need security features in Ruby, right? So the adventures continues. HPKE is just a building block, so I'm trying to get an messaging layer security implementation. That's gonna take a while. And also, now that I came back from the OpenSSL Dungeon Alive, I might continue to dig into this Forgotten Realm and do some stuff in OpenSSL Gem. So shoutouts. These are the people who inspired me to get this talk. And especially major shout outs to Ruby OpenSSL maintainers, especially Radium Town. There's like only 2 people who are like actively like reviewing stuff in OpenSSL. There are like these are super rare people like who can handle like, cryptography code securely. Major shout outs to them. Also shout outs to the past RubyConf speakers, especially Yunosuke-san and Shiroi-san, who did talks on networking protocols, and HPKE implementers, especially Ashitomi-san, who made the JavaScript library. And also shout out to the organizers of RubyConf Taiwan. Thanks for having us here. Thanks for having me here. If you have questions or comments, you can tweet at me at S01, or if you don't like the current Twitter management, I'm also on Fediverse. S01 at Ruby Social. So yeah, that also works. So yep, that concludes my talk. Thank you.
Thank you so much. What an interesting topic. So right now we have like a QA section. There's team who who give you a question like, as someone looking to figure all of this out from the outside, how did it feel to have core algorithm left intentionally documented?
For the reason as to like the OpenSSL stuff are intentionally left undocumented, you have to know you don't get introduced into cryptography through Ruby OpenSSL. You learn your cryptography stuff first in like a different textbook. Like you learn your math and the math that goes into it, and how like the cryptography algorithms work. Then you use if you really have to use the OpenSSL like low level stuff, that's how you get introduced to it. So you as a developer yourself, you don't have to use those undocumented APIs. Like you can use encryption libraries. They are totally fine. Like they are created by people who know these stuff. Like, but if you want to go into building those libraries, you have to know the stuff from different sources. You don't get introduced to cryptography through OpenSSL low level stuff.
Well, thank you for your answer. Did he answer good question? Yes, thank you. Do anyone have a question for him? Don't be shy.
Hi, I want to ask a question in page 68.
Page 68.
Yeah, the example. Just curious, yeah, I'm missing something.
Oh, yeah,
not, but in the line ENC is SCTXU encap a
Encap.
string called some info.
Yeah.
But is it related to the CO, the /x01?
No, it is. They are 2 different stuff.
So the ENC used in is it used in CO? The
No,
ENC.
it's only the string in NCAP and DCAP has to match, and the string in seal and open has to match. But there's a string here and some info and 0x01. These don't have to match. These are like independent values. Like
so, what the /x01 to /x08?
Yeah. It means nothing. It just provides additional context to the like how this is used. So like you can say like you can just say you can put a random string in there, like any random string, but like but the value of that has to match with the open part. So yeah, but you can put any you can pretty much anything.
Okay, so I guess I'm missing something. Just I'm curious about the ENC using center. Which part you use in ENC?
ENC is used in the decap.
Yeah. But so in encrypt parts, you don't use it.
So the encapsulation contains the key, and this decap loads the key into the RCTX.
Okay.
So that so using that key that's loaded into the RCTX, it decrypts the open.
Okay.
Yeah.
it's fine. I guess I know.
Yeah, yeah. Maybe the examples weren't good enough. So like, I have to provide more examples when I'm like releasing these stuff.
Thank you so much. Thank you so much for your questions too. So we gotta move to. I think everyone is hungry now. So